Good morning or good afternoon, depending on when you're watching the video. Yesterday we multiplied and divided. Today we're going to add and subtract. We're still working with rational expressions, so they'll be in fraction form. We're going to go through and add and subtract today. So I'm going to start with a number example just so I can make sure you refresh our memory and all that good stuff before we get into some problems. So let us add 2/9 plus 5/9. When you're adding and subtracting fractions, your denominator has to be the same. So once you're adding and subtracting, if the bottom part of your fraction is the same, you just add or subtract your numerators. So for this particular problem, 2 plus 5 is 9. 2 plus 5 is 7, and then you write the 9 down. I was jumping ahead there. So the 9 just stays where it is, and then 2 plus 5 is 7. So that's how you add or subtract numbers. Now we're going to take this, as always, we're going to upgrade it to Math 3 world. Now we're going to add or subtract these polynomials. Same concept. If the denominator is the same, you don't change it. You just add or subtract the top. So 7y plus y is 8y. The bottom stays the same. If I could break this down some more, I would, but we can't. So we leave it just like that. So your denominators are the same. You add or subtract your numerators. It's just that simple. Let's try another one. Number 2. Okay, lucky us, the denominator is the same, so I just need to subtract my top pieces. Now, I am going to do an intermediate step in here just to make sure we're good to go. So I'm going to write this as 5n minus 3 minus 3n plus 2. And that is all over 6n. So the denominator is the same. And now I'm just going to subtract my numerator like terms. Oops, make sure you can see there. So the denominator is the same, and we're just going to subtract what's on top. So we're going to do like terms. 5n minus 3n is 2n. Negative 3 minus 2 is negative 5. And the denominator stays the same, 6n. And this is our final answer. So we subtracted what was on top. Make sure you keep change. If you need to put a 1 in the front here, if you need to put a 1 here and then distribute, just make sure you're being careful with your signs. So 5 minus 3 is 2. Negative 3 minus 2 is negative 5. Just be careful with your signs. All right, number 3. Oh, good. So we got some more problems where the denominator is the same, so that makes life easier. So I'm going to go ahead and combine my like terms on top. So this is 4x plus 5 minus 6x minus 1. And this is all over x minus 3. So 4x plus 5 minus the whole 6x minus 1 all over x minus 3. So we're going to go through and do like terms. 4 minus 6 is negative 2. 5 minus negative 1 is 6. And this is all over x minus 3. Now, the other ones that we did, we couldn't break those down anymore, but this is a problem that I can simplify and I can break down some more. I can factor the top and I can factor the bottom. Well, I can't factor the bottom, but I can factor the top, and then something's going to cancel. So I pull out the greatest common factor. The greatest common factor is the number 2. And I'm going to take out a negative 2. So negative 2 times what gives me this back? That's an x. And negative 2 times what is going to give me this? That's a negative 3. All over x minus 3. And the wonderful thing with factoring, you can check yourself. Negative 2 times x is negative 2x. Negative 2 times negative 3 is 6. So we're good to go. Now we can cancel those out. Anytime you have the same thing on the top and bottom, they cancel. So our final answer is negative 2. So that's our answer. So notice the progression that we got going on here. We still got the same denominator, but if I can factor it and break it down some more, then I need to make sure I break it all the way down. We're going to do the same thing with number 4. The denominators are the same, so that's good. That's great news. So we're going to add the numerators. Negative x plus 3x is 2x. 1 plus negative 3 is negative 2. And we don't change anything with the bottom. We just bring it on down. Don't change anything about it. Just bring it on down. Now I need to check to see if I can factor, if I can break anything down some more. I can see a greatest common factor here. So we're going to pull out the number 2 because that's the greatest common factor. Everything else is going to go on the inside. So on the inside is x minus 1. I need to break down the bottom. The bottom is the 4-step method, so I'm not going to do all those 4 steps, but I will say them out loud. You multiply the first and last number, factor like normal, divide by the first number, and then get rid of your fractions. Once you go through your 4-step method, that should be on your foldable, so you can keep that out. That's going to factor into 2x minus 5 times x minus 1. Now, when you have the same thing on the top and bottom, it's going to cancel. So x minus 1, x minus 1. Our final answer is 2 over 2x minus 5. So that's our final answer. Now, these first 4 problems that we've done, I've given you problems that have the same denominator. So that's wonderful. I do want to take a look at a couple problems where the denominator is not the same. So how can I make them be the same? So I'm going to go back to this numerical example just to kind of revisit the concept. It may have been a little while since you've done it. So I have this problem here. We're going to do 3/5 minus 7/10. I'm going to show you 2 approaches. The first approach is to find the least common multiple. So if this is 5 and this is 10, I need to make this be 10. So I need to multiply both the top and bottom by the number 2. So that's going to give me 6 over 10 minus 7 over 10. Now that I have the same denominator, that's good. 6 minus 7, my final answer would be negative 1 over 10. Now, other approach, let me rewrite the problem. So this approach is finding the least common multiple. That's what I did on this side over here. Suppose you were busy, you were so into your work, you didn't realize that 10 was the least common multiple. Shortcut that will always work. Take this denominator, multiply top and bottom. Take this denominator, multiply the top and bottom. So take 10 and multiply over here by 10. Take 5, multiply this by 5. So now we have 3 times 10 is 30. 5 times 10 is 50. 7 times 5 is 35. And 10 times 5 is 50. Now I can subtract 30 minus 35. I got negative 5 over 50. I need to reduce this. Negative 5 over 50 is negative 1/10. And we got the same answer. So 2 approaches that we have going on here. Find the least common multiple. The smallest number that your denominators both go into. Find the least common multiple. The other way doesn't really have a name. I guess you call it like crisscross or something like that. That's what I was doing over here. You could just take the separate denominators and multiply the other denominator by it. Either way, you're going to get the same answer. So let's do some problems back in our Math 3 world that do not have the same denominators so that we can talk about how to make the denominators be the same. So let's start with number 5. So this is the first one we've seen where the denominator is not the same, and that's okay. So we can try the least common multiple, meaning I need to make this be the number 6, and I need to add some x's over here. So that's what I'm going to do for this first problem. So if this is a 3 and this is a 6, I need to make this be the number 2. So I'm going to multiply the top and bottom by 2. And this one has 3 x's. This one only has 1 x. So I need to add 2 x's to the problem. So I'm going to multiply the first fraction, top and bottom, by the number 2. And I'm going to multiply the bottom fraction by x squared. The second fraction by x squared. Now my denominators are going to be exactly the same once I multiply. 5 times 2 is 10. If I multiply this, it gives me 6x to the third. 7 times x squared is 7x squared. And if I multiply this, it gives me 6x to the third. Now the denominators are exactly the same. So life is much easier once the denominators are the same. So we add the numerators, which do not have any like terms, all over 6x to the third. You would simplify if you could, but you can't. So we can leave it just like this. 10 plus 7x squared, all divided by 6x to the third. So 10 plus 7x squared, all divided by 6x to the third. So I use the least common multiple method for this problem to get my denominators to be the same. If you don't like that way, just crisscross it. Take this 6x, multiply this fraction by 6x top and bottom, and then take 3x to the third, multiply the top and bottom by 3x to the third. It'll give you the exact same answer. One more, and this one I'll go through and we'll do the crisscross method with this problem here. So 2x squared divided by x plus 1 minus x minus 1 divided by x. So I am going to crisscross. I'm going to take this x, multiply this fraction, and then take x plus 1, multiply this fraction. So I'm going to multiply this one by x, and then I'm going to multiply this by x plus 1. So I took the opposite denominator and multiplied the other fraction by it. They'll always give you the same denominator. 2x squared times x is 2x to the third minus, for the time being, well, I'll go ahead and multiply it out. I was going to write them beside each other, but we're going to have to do the box method or distributive property because you're doing x minus 1 times x plus 1. So we're going to have to multiply all of that out using the box method or distributive property. Once you multiply this out, it gives you x squared minus 1. All right, so off to the side, if you need to do box or distributive property, feel free to do that. And my denominator is going to be x times x plus 1. All right. Now combine like terms, any like terms that we have. I don't have any like terms on the top. So I'm going to bring over the x to the third. This negative gets distributed, so be careful that negative gets distributed. A negative times a negative is a positive. All over x times x plus 1. If I could factor it and break it down some more, I would, but I cannot. So we'll leave our answer just like that. So when you're adding and subtracting, your denominators have to be the same. Once you get them to be the same, you just add or subtract your numerators.